You ever have that moment? Staring at the screen, just waiting for a simple query to even start running.
Oh, yeah.
Yeah,
That blinking cursor.
yeah. And you know it should be quick, but you're stuck watching that spinny circle
Yeah.
for like minutes.
That feeling, that dead time, it's such a common pain point for data folks. And it's something that really jumps out in the sources we're digging into today,
Definitely.
especially when you first compare the experience with the two big players here, Databricks and Snowflake.
Right. And for this deep dive, we've got some really interesting stuff. We're pulling from, a pretty lively Reddit discussion among data engineers, the real raw, unfiltered takes,
Mm-hmm.
and also some detailed comparison articles trying to, cut through the marketing noise.
Exactly. So our goal here is to really pull out the core insights from all this material. We want to understand how Databricks and Snowflake actually stack up in the real world.
What are the actual differences?
Yeah, the experiences, the tech details, the trade-offs, basically how they impact you and your organization when you're using them day to day.
Okay, let's unpack it. Starting right there with that waiting game, the cold start problem.
So the Reddit thread paints this really relatable picture. Imagine you're an analyst, you just need to run one query on a table, but there's no compute running for you right then.
Right, the system's kind of gone to sleep. So what happens next, according to these users and articles?
Well, on Databricks, the sources say getting that compute cluster or SQL warehouse actually ready can take, well, a noticeable chunk of time. Users were talking anywhere from 3 to 4 minutes just for the thing to spin up,
Just to get ready.
just to get ready. And some saw even longer waits,
Yeah.
like 6 to 9 minutes. And apparently in some setups, especially maybe Azure without using pre-warmed pools, it could even stretch to a pretty painful 15, even 30 minutes before you can run anything.
Wow.
And then that very first query you run against that brand new cluster often takes a bit longer too.
Okay, that's a long coffee break just to get started. You're waiting for the engine, then waiting for the first request. What about Snowflake in that exact same situation?
So the contrast there is pretty stark. Snowflake's SQL warehouse typically starts up within seconds.
Seconds.
And importantly, the sources point out even that first query on the fresh warehouse usually comes back fast.
Okay, seconds versus potentially many minutes.
Yeah.
That's a massive difference for someone just trying to get an answer. Why? Why such a gap in that initial startup?
It really boils down to a pretty fundamental difference in their architecture, which the articles get into.
Okay.
With Snowflake, the compute clusters run inside the Snowflake service plane, kind of their own managed environment. This lets Snowflake keep a pool of resources ready,
Ready to go?
and they can basically just assign or wake up a virtual machine for your request almost instantly when it comes in. They control that bro.
Got it. So Snowflake's got the keys to the infrastructure pool and can hand them out right away.
That's a good way to put it. Databricks, on the other hand, at least traditionally, runs its clusters in your plane inside your company's cloud network, your VPC or VNet. So when you need a new cluster or one needs to scale up, Databricks has to actually go and request those VMs from your cloud provider within your network and then start everything up.
Okay.
That whole process just naturally takes longer.
Ah, okay. So it's tied to grabbing the infrastructure in your account versus Snowflake having it pre-warmed in theirs. That user frustration, the waiting, the spinning circles, that definitely comes through in the sources. Did Databricks do anything about this?
Yes, they did. They introduced a serverless option specifically for their SQL warehouses.
Okay.
And this new setup runs the compute in the Databricks plane, much more like how Snowflake operates, precisely to tackle this cold start issue.
And did it work? What are people seeing?
Yeah, users reported much faster startup times with serverless, generally somewhere in the 10 to 30 second range. And Databricks has said they're aiming to get that even lower.
Okay, so they're definitely working on closing that gap. But historically, and maybe still with the non-serverless options, that initial wait time has been a key difference, especially for interactive use.
It's been a really significant point of friction, yeah. Especially for those analysts or data scientists just running ad hoc queries.
Right. Okay, so let's broaden out from just the startup. Performance isn't only about that first query, right? The sources talk about overall performance optimization.
That's a really important point. The Kibo article, for instance, highlights that real-world performance isn't just about raw speed benchmarks. It includes things like how much engineering effort do you need to get that speed? What's the ongoing maintenance cost? How variable is the cost to achieve that performance? They actually call it an effort equation.
Oh, I like that. What is it?
It's like real performance equals query speed divided by the effort the maintenance, and the cost variability you put in.
That's a great way to frame it. It brings in the human cost, the financial side of performance. Okay, so let's look at Snowflake's approach first. One source called it the self-tuning alternative.
Yeah, Snowflake really leans into intelligent automation. When you load data, it automatically breaks it down into these small optimized chunks called micro-partitions. That's key.
Okay.
Plus, it has an automatic query optimizer. It does auto-clustering in the background to keep data organized for speed over time. And it uses pretty robust result caching. So if you run the same query again,
It's fast.
it's instant, potentially. So it's really designed to be smart and performant, kind of out of the box, especially for typical SQL analytics.
Makes sense.
Yeah, it uses columnar storage, vectorized execution, technical terms for fast, and a smart cost-based optimizer that helps it ignore data it doesn't need to read. Users generally report good performance for standard SQL without a ton of tweaking.
And it handles lots of users querying at once pretty well.
Generally, yes. Its multi-clustering feature helps with concurrency, though one source did mention it can sometimes maybe struggle a bit more or need more effort when you're dealing with really complex, nested, semi-structured data compared to just plain structured tables.
Interesting nuance. And there was that specific example about loading CSV files, right? That seemed telling.
Yes, that was quite insightful. A source mentioned they saw a huge speed uploading CSVs, like cutting the time from over a minute down to just 12 seconds.
Wow.
Simply by changing one single configuration setting related to parallel loading in Snowflake. It just shows how Snowflake's architecture is often already geared up for common tasks, needing minimal tuning from the user side for good results.
Okay, so Snowflake, automation, intelligence, ease of optimization for performance. Got it. Now, what about Databricks? The sources called it the high-touch performance machine.
Right. So Databricks is built on Apache Spark. That's its foundation. And Spark was designed from the ground up for really large-scale distributed processing, handling streaming data, complex transformations.
The heavy lifting stuff.
Exactly. And they've built their own high-performance engine on top called Photon, written in C++ Lite. That gives it a significant speed boost, especially for big data sets, complex ETL, streaming.
But the sources suggest getting that peak performance. It takes more hands-on work.
Yes, that's the high-touch aspect. You often need to actively manage performance yourself. Things like choosing the right way to partition your data tables.
How you chop them up affects speed.
Absolutely. Applying things like Z-ordering, which is a technique to group related data physically closer together for faster reads. You also need to do regular maintenance on Delta Lake tables, like running Optimize to combine small files into bigger ones.
For efficiency.
Right. And VHUM to clear out old data files, which saves storage costs too. And often you find yourself needing to tweak Spark's own configuration settings for different kinds of jobs.
So incredibly powerful, incredibly flexible, but you need people who really know how to tune it, like maintaining a high-performance race car engine.
That's a good analogy. And configuring it for optimal concurrency, especially if you have lots of different types of queries hitting it, is also generally seen as more complex than Snowflake's simpler multi-cluster setup.
But there's a key area where Databricks shines, according to the sources.
Yes, a big one. Native, deep support for distributed machine learning and AI training. It has strong GPU support, tight integration with tools like MLflow. This is a core strength, a primary use case where Databricks often has a clear advantage.
Okay, which brings us neatly to that slightly spicy topic of performance benchmarks, especially TP-CDS. That seems to be a real battleground.
Oh, it definitely stirred up a lot of debate in the sources. Databricks came out with results claiming new world records on the 100 terabyte TP-CDS benchmark.
Setting records.
Yeah, saying they significantly beat Snowflake, and importantly, that their results were formally audited.
Okay, and Snowflake's response.
Well, Snowflake pushed back pretty hard. They basically called these benchmark wars old school marketing tactics.
Been there, done that.
Right. Arguing they don't really reflect how most customers actually use the platform day to day. They claim Databricks numbers for Snowflake weren't transparent, weren't audited, couldn't be reproduced, and just didn't match Snowflake's own internal tests or what customers were seeing.
So questioning the whole comparison, basically.
Absolutely. Snowflake then published their own TP-CDS results. They showed their 4XL warehouse finishing the benchmark much, much faster than Databricks had reported for them.
Okay.
And on the cost side, they said their run cost just $267. That was way less than the, nearly $1,800 Databricks had reported Snowflake's cost would be.
Big difference.
Huge. Snowflake clarified that if you use their standard edition pricing, their cost, that $267 was actually very close to Databricks' audited run cost of $275. They argued Databricks' initial cost comparison was misleading, maybe using higher Snowflake editions or not optimizing things properly.
And Snowflake even said, don't just trust us.
Yeah, that was clever. Their blog post had a trust but verify section. It basically showed how any user could run that same TPCDS benchmark themselves on their own Snowflake account pretty easily, maybe in an hour or so for a few $100.
Kind of calling their bluff, or at least encouraging transparency.
Exactly, highlighting the simplicity of getting real performance data on their platform.
So the takeaway is, benchmarks are benchmarks? Maybe don't rely just on them. Try it yourself.
Precisely, and it's a really important point from the discussion. TPCDS is a specific kind of analytics benchmark. It's not necessarily representative of every workload out there. Real-world use cases are often way more varied.
Okay, good context. Let's switch gears then. From performance to the dollars and cents. Cost. How do you actually pay for these things? What are the big cost drivers?
So both platforms use usage-based pricing. Snowflake has its credits. Databricks has its DBUs, Databricks units. You pay for what you use.
But the how you use it matters.
Oh,
right?
absolutely. That's where the key differences lie.
Okay, tell us about Snowflake's cost model first.
Snowflake's main cost is compute, billed through credits for those virtual warehouses and also for serverless features. But the really key thing, and a major cost control lever, is that Snowflake bills for actual runtime, down to the second.
So if your warehouse isn't actively crunching numbers, you stop paying for compute.
Exactly that. The auto-suspend feature is massive here. An idle warehouse costs you 0 in compute credits.
That seems huge for controlling costs, especially for intermittent workloads.
It is. And scaling costs are generally pretty predictable. You double the warehouse size, you roughly double the credit consumption per hour. Storage is charged separately based on compressed data size. And like any cloud service, you got to watch out for potential hidden costs like data transfer, especially moving data out.
Right. Egress fees.
Yeah.
And connecting back to that benchmark cost argument.
Yeah, as we mentioned, Snowflake made a point of showing their TPCDS run costs $267, arguing Databricks' initial claim of nearly $1,800 for them was way off, and that their actual cost matched Databricks' audited number closely when using a comparable edition. It highlights how configuration choices impact cost, and Snowflake's angle is that their standard setup makes achieving cost-effective performance easier out of the box.
Okay, so Snowflake, pay-per-second compute, auto-suspend is your best friend, predictable scaling. Got it. How about Databricks' cost model?
Databricks uses those DBUs, but the price per DBU isn't flat. It varies quite a bit depending on what you're using it for.
Like what?
Like all-purpose clusters for interactive work have one rate, jobs clusters for automated ETL have another, SQL warehouses another, and serverless SQL yet another different DBU rate.
Okay, so more variables to track.
A few more, yeah. And the actual DBU consumption also depends heavily on the underlying cloud instances. You pick the VM types, the sizes, and how you configure the cluster overall.
So it feels like there's maybe more potential for costs to fluctuate if you're not careful.
It can be less predictable initially, perhaps. The DBU cost bundles both the Databricks platform fee and the cost of the underlying cloud infrastructure together. So this means you really need careful cluster management. You need to set up auto-scaling correctly, define termination policies, because if you don't configure clusters to shut down when they're idle, you will pay for those servers sitting there doing nothing.
Unlike Snowflake's auto-suspend.
Right. There's also a potential risk of what they call resource sprawl, ending up with lots of different specialized clusters for different tasks, which can become complex and costly to manage.
What about hidden costs on the Databricks side?
Similar to Snowflake, data transfer is one, but the sources also flag potentially higher operational overhead as a kind of hidden cost, meaning the extra human effort needed for administration, monitoring, and that ongoing optimization required to keep performance up and costs down compared to Snowflake's more automated nature.
So this leads to sort of different philosophies on managing cost.
Exactly. Snowflake's automation, especially that auto-suspend and predictable scaling, gives you what one source called a simplicity premium for cost management. It's often easier to get a handle on costs up front.
Whereas Databricks demands more active management, maybe an engineering tax, as it was put.
Yeah, that phrase engineering tax captures it. But, and this is important, that extra effort can potentially lead to lower overall costs, especially for very predictable, steady workloads like big, regular ETL jobs.
How so?
Because you have more direct control. You can fine-tune the cluster types, the instance sizes, maybe leverage things like reserved instances from your cloud provider since that infrastructure runs in your account.
Right, you can optimize the underlying cloud costs more directly.
Potentially, yes. So it's that classic trade-off. Simplicity and predictability out of the box versus potential for deeper optimization and control, but requiring more engineering effort.
That seems like a really crucial distinction coming from the sources.
It's definitely one of the core comparisons.
Okay, let's maybe circle back to the architecture for a moment, just to understand why these platforms lend themselves to different things. What's the core design philosophy?
Good idea. So Snowflake's architecture is, well, it's fundamentally cloud native. It was designed from the start as a fully managed service, aiming for almost zero maintenance from the user's perspective.
Set it and forget it, ideally.
Kind of, yeah. It has that really clean separation of storage and compute. Your data lives in their proprietary, highly optimized micro-partitioned format. And compute is handled by those independent, elastic virtual warehouses that can scale up or down really quickly without affecting storage or other warehouses. It's very much a SQL-first system.
Optimized for SQL analytics.
Deeply optimized for structured data analytics, yeah. And it has those really powerful built-in features people love.
Like data sharing, time travel.
Exactly. Data sharing lets you securely share live data without copying it. Time travel lets you query data as it looked in the past, amazing for rollbacks or analysis. And cloning lets you make near-instant, zero-cost copies of huge databases for development or testing. Huge value adds.
Okay, now, Databricks architecture, quite different.
Very different foundation. It's built on Apache Spark. That inherently makes it super strong for large-scale distributed processing, handling all sorts of data formats, including streaming, and enabling really complex transformations using multiple languages.
Not just SQL.
Right. It positions itself as this unified platform, data engineering, data science, ML, analytics, all in one place. And a core principle is that your data lives in open formats like Parquet or Delta Lake directly in your cloud storage, your S3 bucket, your Azure Data Lake storage, your Google Cloud storage.
So you own the data in an open format, and Delta Lake adds the structure on top.
Precisely. Delta Lake brings those crucial data warehousing capabilities, ACD transactions, ensuring data integrity even when lots of things are happening at once, brings those features to your data lake files stored in cheap object storage.
Reliability for the data lake.
That's the idea. Plus, Databricks natively supports multiple languages side by side: SQL, Python, R, Scala, and they have Unity catalog for governance across everything, including things like automatic data lineage tracking, which is super useful for understanding data flows.
Okay, so with those distinct architectures, how does this translate into ideal use cases? Where does each one really shine, according to the sources?
So, based on the discussions and articles, Snowflake really excels in scenarios that are heavily driven by SQL analytics, traditional business intelligence, BI, and reporting.
The classic data warehouse use cases.
Exactly. Its strengths in governance, that easy and secure data sharing, and how well it handles structured data and increasingly semi-structured too, make it a fantastic fit for teams where SQL is king, who want a fully managed service and want to keep operational overhead low.
It sounds like it's really built for the data analyst, the BI developer, who wants reliable SQL performance without messing with infrastructure.
That captures it well, I think. Databricks, on the other hand, tends to be the preferred choice for machine learning and AI workloads.
Because of Spark and ML flow.
Yeah, and its native handling of libraries, GPUs, also for real-time streaming data processing and those really complex data engineering pipelines, especially if they involve more than just SQL Python, Scala transformations. It's often better suited for digging into unstructured data, too.
And for teams with maybe stronger programming skills.
Right. Teams with strong engineering and programming chops who need that fine-grained control over the processing and want that unified platform for both batch jobs and streaming data.
This naturally leads us to the lakehouse concept that's talked about so much.
Yeah, Databricks is arguably the biggest champion of the lakehouse idea.
Which is?
The concept is basically to combine the cost benefits and flexibility you get with data lake storage, like storing raw data cheaply, with the structure, performance, and governance features you typically associate with a data warehouse.
Best of both worlds.
That's the pitch, primarily achieved through Delta Lake sitting on top of your data lake, plus their Spark and Photon engines for processing. Their vision is that the lakehouse can potentially replace the need for a separate traditional data warehouse entirely.
Okay, But Snowflake isn't just ignoring this trend, right?
Oh, definitely not. The sources point out Snowflake is also enabling lakehouse-style patterns. For instance, Snowflake can now query external tables directly data stored in open formats like Iceberg or Parquet that lives in your own S3 or ADLS.
So you can access data lake data without first loading it into Snowflake storage.
Exactly. It lets you leverage some of those data lake assets directly. So you see both platforms evolving and really blurring the lines. Snowflake's adding more programming capabilities with Snowpark letting you run Python, Java, Scala code within Snowflake.
Moving into Databricks territory a bit.
You could say that. And Databricks is constantly improving its SQL performance, adding more warehouse-like features, enhancing Unity Catalog for governance.
Moving into Snowflake's territory.
Right. The lines are definitely getting fuzzier. Which means it's really not a simple either-or decision anymore, if it ever truly was.
Yeah, the sources seem very clear on that. There's no single best platform for everyone. It really depends.
Absolutely. The optimal choice is super dependent on your specific context, your needs, your team.
So what are the most critical things someone should think about when making this choice, based on what we've read?
Okay, first off, you need an honest look at your main workloads. Is it mostly SQL Analytics and BI? Or is it heavily geared towards ML, AI, streaming, complex data engineering? Is it mostly batch or real-time sensitive?
Know thyself, basically.
Exactly. Second, what about your team? What skills do you actually have? Strong SQL folks or more Python Scala Spark developers? And critically, how much engineering time and capacity do you realistically have available to dedicate to platform tuning and maintenance?
That links back to the cost discussion, too.
Definitely. How sensitive are you to cost variability versus predictability? Are you willing and able to invest engineering effort to potentially squeeze out lower costs? Or do you prefer paying a bit more maybe for a fully managed service with simpler, more predictable costs?
Other factors.
Yeah, consider your existing tech stack, your preferred cloud provider alignment, your specific needs around data governance and security. Both platforms are strong here, but have different approaches.
And one source made a really good point that how you implement it matters a ton.
Oh, that's crucial. A poorly designed or managed system on either platform is going to cost more and perform worse than a well-architected one. Getting the setup, the data models, the job scheduling right, that's key, regardless of the underlying tech.
So given these distinct strengths, but also the blurring lines, is using both platforms a common thing people do?
Very common, according to the sources we looked at. Lots of organizations end up using a hybrid approach.
How did that work?
They essentially leverage the best of both. They might use Databricks for the really heavy data engineering, the complex transformations, training ML models where Spark and its flexibility shine.
The factory part.
Kind of, yeah.
Right.
And then they might use Snowflake for the downstream BI layer, the reporting, dashboards, and maybe for its centralized governance and data sharing features because of its SQL speed and ease of use for analysts.
Makes sense. Use the right tool for the right job.
Yeah.
But that must add complexity.
It absolutely does. You now have to manage the integration, the data movement, ensuring consistency, controlling costs across two different platforms. It needs careful architecture.
Yeah, not trivial.
And the sources also briefly mention that migrating entirely from one platform to the other is often a major undertaking, costly, complex, time-consuming, which is another reason why that hybrid model often emerges as a practical way forward rather than a big bang switch.
Okay, wow. We've really covered a lot of ground here, diving deep into Databricks versus Snowflake based on these user experiences and analyses. Let's try and boil it down. What are the core takeaways?
All right. So based on everything, Snowflake's core proposition is really about simplicity, excellent SQL performance, often straight out of the box, and that automated management, especially around cost control with things like auto-suspend. That makes it a really strong choice for teams focused on BI reporting, where SQL is the primary language, and who value ease of use and predictable costs.
Got it. Simplicity and SQL strength. And Databricks.
Databricks brings the power, the flexibility, that unified platform vision, especially excelling in MLAI and complex data engineering that goes beyond SQL. It fits well for teams with stronger programming and Spark skills who need that fine-grained control, maybe handle lots of streaming data, and want one environment for diverse workloads.
Power and flexibility, especially for engineering and ML.
Exactly. And the real so what here, I think, is that this choice isn't just about ticking feature boxes on a technical checklist. It's fundamentally a strategic decision.
How so?
It needs to align with your team's actual skills, your organization's budget approach predictability versus optimization effort, your tolerance for operational overhead, and what your primary business goals are for this data platform. What problem are you actually trying to solve?
Right.
And the sources really emphasize that performance today. And looking ahead to 2025 isn't just about winning some benchmark race. It's increasingly about intelligent scaling, getting real ROI, and truly understanding your total cost of ownership, compute, storage, and that human engineering effort needed.
That holistic view of performance, the effort equation idea, feels really important. And it kind of leaves me with the final thought, building on that constant evolution we saw mentioned. Both platforms are clearly racing to add capabilities the other was traditionally known for. Snowflake, adding Snowpark for coding, Databricks boosting its SQL and warehousing features. So, given this convergence, is the future just one giant do-everything platform, or will those fundamental architectural differences we talked about always mean there's value in specializing, or even in using both side by side, like many do now?
That's the multi-billion-dollar question, isn't it?
And maybe which platform, based on where they started and where they seem to be going, is actually better positioned to potentially unify it all in the long run. Definitely something to chew on as you think about your own data strategy.